Hi, we're going to look at factoring some numbers. So check this out. Here we've got a chain of blocks. What I usually ask a student to do is see how many rectangles they can make out of these 12 blocks. So they'll start and they'll make a long chain. So 1 this way, 12 this way, and the area is 12. And they can break it in half and say, oh, I can make another rectangle, 2 this way, and then 6 this way. And I can do it in a different orientation, but the factors are still going to be 2 and 6. And then they can try with 5, but it's not going to work. If they take a couple of these off, they can reallocate them and make something that's going to be 4 one way and 3 the other. So 3 and 4 are also factors of 12. All right. So let's look at those same patterns here. These are those same rectangles I just made. 1 and 12 are factors of 12. 2 and 6 are factors of 12. And 3 and 4 are factors of 12. What I'm going to show you how to do is to do this all in one dynamic process. So if I start here with this top rectangle and put that in, and again, if you use lined paper perhaps eventually, you won't have to have as much trouble drawing the rectangles, but here's that same first rectangle. 1 times 12 is 12. Or if you know you have 12 and divide it by 1, 12 divided by 1 is 12, just like a long division problem. 12 is an even number, so it can be divided in 2. So yeah, 2 is a factor. So you cut this in half. We still have 12. 2 is one factor, and 12 divided by 2 is 6. We try 3 now. The digits of 12 add up to 3. If they add to 3, 6, or 9, it's divisible by 3. So here's my division problem. 12 divided by 3 is 4. When these numbers get 1 apart, you know you're done. So here's how you actually do this without having a template. So we put in what the product is, 12. Divided by 1. So 12 is, 1's the factor of everything. So 12 and 1 are factors, and that would be 12. It's an even number, so yeah, it's divisible by 2. Break this in half, and we get this rectangle up here. So it's still worth 12, and 12 divided by 2 is 6. All right, so we've got 2. Let's keep going in order. 3, the divisibility rule for 3 means if you add the digits of 12, and they add to 3, 6, or 9, it's divisible by 3. It is, so we're going to go ahead and break that up, and 12 divided by 3 is 4. When these become just 1 apart, you know you're done. Or if it becomes a square, it's done. Let's look at one other similar example here. This is 18. Here's the template. I'm skipping right down to here. So I'm going to say there are 18 blocks, and I can always make that into 18 single pieces. So 18 divided by 1 is 18. It's an even number, so it's divisible by 2. So break this in half. And now we still have 18, and 18 divided by 2 is 9. So 2 and 9 are factors. All right, so let's try 3. 8 and 1 add up to 9. If the digits add to 3, 6, or 9, it's divisible by 3. So let's look at 18 divided by 3, and that is 6. 6 times 3 is 18. So we could try 4. The way you can test that is if you look at when you divided it by 2, you got 9. If this was an even number, it would be divisible by 4. It's not. So 4 doesn't work. Let's try 5. Anything times 5 ends in a 5 or a 0. That's no good. So now we're 1 away. We're done. So those are the factors. I'm going to show you one last one. It's a little bit harder, but you might as well see how you can use that division idea. So we're going to do 30. Of course, it's divisible by 1. So here's our division problem. So 30 divided by 1 is 30, but we could do it one chunk at a time. How many ones are in 3? 3. How many ones are in 0? 0. You can do it like a long division problem. It's even, so we're going to go with 2. Break that in half. Do this like a long division problem if you're not sure. How many 2's can you get out of 3? 1. 1 times 2 is 2. Subtract, you get 1, bring down your 0. How many 2's are in 10? 5, so 15 up there. All right, let's try 3. Is it divisible by 3? Yeah, the digits add to 3, 6, or 9. They add to 3. So we know it's divisible by 3. We put the 30 down here. Do a long division problem. How many 3's are in 3? 1. 1 times 3 is 3. Subtract. We get 10. All right, so we can keep trying. We could try 4. This is not even though, so it's not, 4 is no good. Let's try 5. It ends in a 5 or a 0, so that looks good. How many 5's are in 30? I know that fact. That's 6. 6 times 5 is 30. Hit it perfectly. We're 1 apart. We're done.